So let's talk about day 2 of quadratic functions. So let's look at this graph right here. What's the first thing I would do with this? Factor out a -2, and I would get 2x plus 8x minus 8x, thank you, minus 8x plus 9. No, it's close. Okay, guys, let's calm down. All right, so is this factorable? No. It is not factorable. No, it's not. I'm going to tell you. Explain. It looks factorable, but it's not. This is a squared. 2x squared goes here, 9 goes here, right? 2x times 9 is 18x squared. My -8x goes down here, right? Is there two numbers that when I multiply I get 18 and when I add them I get -8? Right? Is it factorable? It's not factorable. I'll tell you exactly why it's not factorable. Look at this graph right here. I'm guessing that this is negative, right? So it's going to go down. It's never going to hit the x-axis. That's what the roots are, right? That's what the zeros are. The zeros are where it's going to hit on the x-axis. This is not going to hit on the x-axis. Not every graph passes the x-axis. That's when it's not factorable, right? So let's take that and say to ourselves, if I'm going to factor and solve if possible, but if not, I'm going to write myself a t-table. But I'm not going to do it traditionally like you use a t-table. I'm going to use an educated guess on what I need to put in that table. I'm not just going to throw values in there. So I'm going to start with my axis of symmetry. X equals -b over 2a. That's why I had you practice that yesterday. Because now you've got to use it. Because you don't have anything else to go off of except for that axis of symmetry. So -b, b is 16 over 2 times a, which is -4. I'm using the original equation. You can use this one, but then you've got to remember to multiply by -2. I don't want to have to forget about that. So I'm just going to use the original. So I get -16 over -8 is +2. That's my axis of symmetry. So I go to 2, draw my axis of symmetry. Next, I want to know if I put 2 in to my function, what am I going to get out for y? Because that's called my what? What's going to be on this line? My vertex. That's my first value that goes in to my table, 2. When I put 2 into my function, I get -4 times 2 squared plus 16x minus, 16 times 2 minus 18. I need more room. So I get this is 4 times 4 is 16, -16. I've got 2 16s here, right, which is 32. I'm going to just leave them as 16. That's what I'm saying, right? 2 16s? That way I can say this is 0 pair, so this is -2. I plug in 2, I get -2. 2, -2. There's my vertex. What's the next thing I would do? So now I'm using my table. I've got my axis of symmetry and my vertex. I already know it points up or down because it's a negative graph, so it's going to point down. So I need to plug in what? Or find my y-intercept, and my y-intercept is always c. Because if I put 0 in here and 0 in here, they're both going to cancel out, right? I don't want to cross those off, though. So when I put in 0, I get, for all purposes, I need to see that. You don't have to write it out. You can just put f of 0 equals -18. Okay? That tells me that you know what you're talking about. So finally, let's plot that. What's another point I could plot? 4. I can see it. I've got to prove it. Okay? So let's prove it. Let's put in 4. I should get what? I should get -18. F of 4 equals, what was it? I can't see it, but it's 4 squared plus 16 times 4 minus 18. This is -64, and positive 64 minus 18 equals -18. Symmetrical, we're good. I'm going to go up and graph it because I can't graph it. Let's talk about behavior. It's pointing down. What does the 4 tell me in behavior graph? It's skinny, right? It's very steep. Does that look steep to you? Does it look like we've done this correctly? Because of, do you see what I'm saying by, the book wanted me to start this chapter with you just graphing this using a t-table. But since I decided to start with the factoring and talking about axis of symmetry and talking about vertex and behavior of graphs, now you can see it. You don't need a table, right? I mean, you can use a table, but is it valuable to just start plugging just random values in and just seeing what happens? No, you got to talk about what it's supposed to look like, what you can get out of it. Yes?
So if it doesn't factor, then it means it's not going to get the.
We'll talk about that in just a second. Good question. Excellent, excellent question. Because that's exactly where I'm going with this. All right, so I'm going to pass this out, and I'm going to have you guys copy this one down. Sorry, let's finish it. So E would be minimum or maximum?
Maximum.
Maximum. And F would be my domain and range. My domain is? You guys got this. All real numbers. And my range is? You guys got it. You were all scared of that before, and you're doing so much better. I can't hear exactly what you're saying. What? Yeah, it does matter. Because if you just said less than, that would be a graph that looked like this. It does matter, right? The graph would say all these values except for that one. Right? Does that make sense? Okay, so let me fix that. And let me pass this out for you guys. What we know about graphs means that it's going to be negative. It's going to be a normal shape like a parent graph, and it's going to be down here at -6 because my constant is -6. With that information, let's make some educated guesses. I'm always going to begin with my axis of symmetry, which is -b over 2a. If this is a, and this is b, and this is c, -b would be -6 over 2 times -1, which would be -3. So my axis of symmetry is at -3. So that first value that I want to substitute in would be -3. Right? I want to find where my graph is going to lie on this axis of symmetry. So I'm going to substitute in -3, right? This number right here is my first value that goes in my table. So f of -3 equals -3 squared minus 6 times -3 minus 6. What is that? -9 plus 18 makes positive 9, minus 6 makes positive 3. Am I right? So when I substitute negative 3, I get positive 3. Uh-oh. Hold the phone. Check this out. It's going to be negative, right? But that means it's going to be going down like this, because I know that my y-intercept is down here. It's crossing the x. Is this factorable? It's not. How can that be? Mrs. Muller said that if we factor, we get zeros. Think about that. Think about everything you know about algebra. I know that they did it very piecewise. You just talked about factoring, 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 right? Then you went on to the next section. What was that next section? No, it related, but nobody really tied it back in probably for you. Nobody's got it? Nobody can think of how in the world, if this is not factorable, does my parabola cross the x-axis? It does. Let's keep going. I can't plug in 6 because I don't have enough graph down here. So what would you like to substitute in next? You want to go all the way over here? You can't. Look it. If you go way over here, it's going to be way, way down here. I put in positive 1's way over here. That'll be way down here. I can't graph that either. Don't I want to stay next to my axis of symmetry? I would either go with -1 or -2. Let's go with -1. That's easier to plug in than -2, right? So let's do f of -1. Let's see what happens. -1 squared minus 6 times -1 minus 6. What do we get? Do we get 1? We get -1. So if I substitute in -1, I get -1. -1, -1. It's going in that direction, right? I've got one more point to plot. What would I put in? -5, and I should get -1, right? All the way over here, it should be symmetrical. Let's see what happens. -5, I get -5 squared minus 6 times -5 minus 6. This is -25 plus 30 minus 6 is -1. It does cross. How can that be, Jesus? Wouldn't it have roots then? That is not a good graph. It should look more like. Now, can you tell me what happened? It doesn't cross at a point. I didn't hear it. It passes through 2 points. You can't see that factoring, right? So the only way you could find that would be what? What? When you can't factor something, what do you use? The quadratic formula, right? The quadratic formula is the one that will give us decimals or radicals, right? I'm not asking you to do it. Somebody freaked out on me last period, and they're like, oh, don't make us do the quadratic formula too. And I'm like, no, I'm just trying to say that's where you would get those roots. Yes. This one right here, because my constant is -6, so my y-intercept, if I were to plug in 0, would be -6. So I knew that this graph was going to cross down there. I just can't graph it. Does that make sense? Yeah. Any more questions right now? Oh, we have to do our minimum maximum. Is this a min or a max? It's a max. And my domain and range, what's my domain? All real numbers. And what's my range? Y such that Y is less than or equal to, right, Jesus?
Yes.
Less than or equal to what?
I'm going to change that right now.
Good. 3. Questions? Patricia, better? The second time's better, right? All right, do you guys still need this to copy it down for a quick second? Okay. Okay, so let's do this one together. We're going to start with our axis of symmetry, so negative b over 2a, which equals negative 8 over 2 times 2, which is positive 8 over 4, which is positive 2. My axis of symmetry, did I do something wrong? No? Okay. My axis of symmetry is right here. 2x squared. What type of behavior would that be? It would be kind of steeper and it would be in the positive direction, right? So let's keep that in mind. This one's a little bit easier because I've got this right here. What does that tell me? My constant. Hold on. What does my constant being 12 tell me? That that's my y-intercept. Here's my table. What's the first thing I'm going to put in my table? 2. So f of 2 equals 2 times 2 squared minus 8 times 2 plus 12. 4 times 2 is 8. Minus 2/8 is a positive 8. 8 plus 12 is, that's not right. 2 times 2 is 4. 4 times 2 is 8. Minus 16 is negative 8. That's I did wrong. Negative 8 plus 12 is positive 4. 2, 4. Does it look like it's going to go a little bit skinnier?
Yeah.
It does. So what's the last point I need to put in here? 4. Oh, we need to actually put our 0, right? F of 0 is 12, because I need 3 points in my table to get full credit, right? So if my last one is 4, so F of 4 equals 2 times 4 squared minus 8 times 4 plus 12. Four times 4 is 16. 16 times 2 is 32 minus 32 plus 12. So it works, right?
Yeah.
So there's my graph. Question?
Yes. Are there any that are calculable?
Are there what?
Any that are calculable? Yeah.
All right, what's my max or minimum? Minimum. What's my domain? All real numbers. And my range? Greater or equal to 4. Good job, guys. People still copying down? Okay, let me give you a second. There you go. Good. Okay, so what did we do today? What did we learn? You can still solve without what?
Without y,
Without factoring. Good. Good. Use that academic vocabulary. All right, listen up. Name the components to consider when graphing a quadratic. What's the first thing to consider? No, that's different. That's when factoring. We're graphing a quadratic. What's the first thing you consider? No, we're graphing. Strictly graphing. Before the vertex, the
oh my God,
axis of symmetry. Then we go for the vertex. Then we go for the y-intercept, right? So axis of symmetry, then vertex, then y-intercept. The person next to you is absent. How would you explain when you need to make a table? When do you need to make a table? Josiah. I sure can. Can you tell me, Josiah, when you need to make a table? When you can't factor. On your assignment sheet, I will always check for what and what before I try to factor. Greatest common factor, and what else? You should look for negative, good, but before that you should always be looking for greatest common factor and squares. You should be looking for squares. Good job, guys.